Ladies and gentlemen, boys and girls, welcome to another video. Please hit the like button, hit the subscribe button, and hit the notification bell so you will be updated on all my future content. Welcome to the Fraction Satisfaction live stream. So this live stream is going to be focusing on all things fractions. The first portion of this live stream is going to focus on how to identify different fractions. And as people come into the chat, we'll go with whatever the people in the chat need help with, whether it's adding fractions, subtracting fractions, converting fractions with unlike denominators. We'll go with the flow a little bit. But first portion of this was going to be identifying fractions and explaining what a fraction is. So a fraction represents a parts to whole relationship. So the bottom number in a fraction, aka the denominator, is the total amount of pieces within the fraction. So this fraction here, for example, has a total of 1, 2, 3, 4, 5, 6, 7, 8 parts. It has a total of 8 equal parts. Now the numerator represents the portion that is either shaded or unshaded. So for this live stream, we'll go with the shaded portion. So if we want to count how many parts of this fraction are shaded, we have 5 that are left blank, and then we have 1, 2, 3 that are shaded blue. So 3 out of the 8 parts are shaded. So this fraction motto represents the fraction 3/8. All right, moving on to the next fraction example. It's the Mr. Camilleri show. It's the Mr. C. It's the Mr. Camilleri show. All right. This is the Fraction Satisfaction live stream. This first portion is identifying fractions. So I'm going to make a fraction motto here. I'm going to explain how to identify the fraction that this model is representing. So fractions represent a parts to whole relationship. So the bottom number in the fraction, aka the denominator, represents the total amount of equal parts. The bottom number represents the total. So in this fraction model here, we have a total of 1, 2, 3, 4, 5 parts. So 5 would be the denominator in this fraction. The numerator represents the parts shaded or unshaded. So in this fraction, we have 2 parts that are shaded. So if we're looking for the fraction of shaded parts, or the fraction that's shaded red, we have 2 out of the 5 pieces shaded red. So this fraction model represents the fraction 2/5. All right, moving on to the next example. Shout out to everybody tuning in. Please hit the like button. I appreciate you. It's the Mr. Camilleri show. It's Mr. C. It's the Mr. Camilleri show. Shout out to Mr. C. So again, to find our denominator, we're looking for the total amount of equal parts within the fraction. Now, I'm not the best artist. I tried to make all these parts look equal. I'm not always as precise as I want to be, but for all intents and purposes, let's assume all these parts are equal. All right. So the denominator is the total amount of parts. So we have 1, 2, 3, 4, 5, 6, 7, 8 total parts within this fraction. Now we're looking for the fraction of the parts that are shaded. One of the 8 parts is shaded. So this fraction model represents 1/8. All right, moving on to the next example. I think I'm going to put a poll up. I'm going to put a poll up so everybody in the chat can vote on what the next concept for fractions is going to be. So we're putting a poll up right now. Going to do a couple more examples of identifying fractions, and then we're going to put a poll up to so the people in the chat can vote on the next concept. So the poll is up. So I'm going to keep going with this same thing until about the 10-minute mark, 12-minute mark. Then you guys can vote on what you want the next concept to be. So after I finish with the identifying fractions, do you want to focus on adding and subtracting fractions or converting improper fractions to mixed numbers? Shout out to everybody that voted. At the 12-minute mark, I'm going to check the votes. All right, next example. Next example coming up. All right, so we are identifying the fraction that this model represents. So to find the denominator is the total amount of parts. So we have 1, 2, 3, 4, 5, 6 equal parts. They might not look equal, but again, they're supposed to be equal. My drawing might not be exact. And now we're trying to find what this model, the fraction model that it represents for the parts that are shaded. We have 1, 2, 3, 4, 5 parts shaded. 5 out of the 6 total parts are shaded. So this fraction model represents 5/6. I'm great. How are you? I am back. Yes, I'm back. Shout out to everybody that's here. Please vote. All right, next example, please please vote on what the which concept you would prefer for me to move on to. If it's 2 votes and it's 1 each, then it's going to be like a split decision. You know, I'd rather leave it up to the chat. Now, this is going to be a little complicated, but we're going to do our best here. All right. So again, the denominator is the total amount of parts. So we have 1, 2, 3, 4, 5, 6, 7. Oh, let me start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 total parts. So 16 is our denominator, and 1, 2, 3, 4 of the parts are shaded. So this fraction matter represents 4/16. All right, I'm going to check the poll right now. Now, I know that last fraction is not in lowest terms. Reducing fractions to lowest terms, that's another concept that we can maybe look at. I need more people to vote. It's 50-50. Oh, 50% said yes, and then 50% said, all right, improper fractions to mixed numbers. So that's what we'll do next. That'll be our next concept. So 0% for add, subtract fractions, 0% for no, 50% for yes. The yes, no probably shouldn't have been in the poll. That's my bad. But we'll go with improper fractions to mixed numbers. All right. So converting improper fractions to mixed numbers, think of that as division with remainders. Division with remainders. So we have 5/3 here, and we have to convert that into a mixed number. So we have to figure out how many groups of 3 we can get into 5. So what I'm going to do is I'm going to make groups of 3. There is probably going to be a remainder here. So we have 1, 2, 3. That's one full group of 3. That's one whole. 1, 2. So we were not able to get a second full group of 3 in there, but we were able to get one full group of 3. So 1 is our whole number. Now here's how we determine what the fraction next to the whole number is for our mixed number. Whatever our denominator is in the improper fraction, that's going to stay the same. So 5/3, our denominator is 3. 3 is going to be the denominator when we convert it to a mixed number. Now our numerator is whatever our remainder is. Whatever our remainder is, that's our numerator. So as you can see here, we had a full group of 3, and then we had a remainder of 2. We weren't able to get a full second group of 3, but we had 2 remaining. So 2 is going to be our numerator. Our remainder is our numerator. So we have our final answer. 5/3 converted to a mixed number equals 1 2/3. All right, moving on to the next example. Shout out to everybody tuning in. I appreciate you. I am glad that you are here. All right, 14/5. So we got to figure out how many times the denominator goes into the numerator. So we have to figure out how many groups of 5 go into 14. So what I'm going to do is I'm going to make groups of 5. 1, 2, 3, 4, 5. That's one group of 5. 1, 2, 3, 4, 5. That's two groups of 5. I have 10 tallies total so far. Now 11, 12, 13, 14. So I got my 14 total tallies. Within those 14 tallies, I was able to get 2 full groups of 5. So 2 is our whole number here. Now to determine the fraction that goes next to the whole number, as I've said, the denominator stays the same. Our remainder is our numerator. So we have a remainder of 4. So 4 is our numerator here, and 14/5 converted to a mixed number equals 2 4/5. Next example. (13/3). So we have to figure out how many groups of 3 go into 13. So we are going to make 13 total tallies. We're going to make them in groups of 3. We have to figure out how many full groups of 3 we get. We got to see what our remainder is. So 13 total tallies we're going to make. 1, 2, 3. That's one group of 3. 4, 5, 6. That's two groups. 7, 8, 9. 3 groups of 3 there. 10, 11, 12. That's 4 groups of 3. Now we have our 13 total tallies. So we were able to get 4 full groups of 3 within 13. So 4 is our whole number. The denominator in our fraction stays the same. Somebody in the chat just put what he thinks the answer is, what he or she thinks the answer is. We'll see if they're correct. So the denominator stays the same. Our remainder is our numerator. We have a remainder of 1, and the answer is 4 1/3. Shout out to the person that figured it out and put the answer in the chat. Very good. It's the Mr. Camilleri show. It's the Mr. C. It's the Mr. Camilleri show. Next example. Thinking of putting another poll up, but 7/2 or 7 seconds. We have to convert that into a mixed number. Before I convert that, let me put a poll up for what the next concept's going to be in fractionation. I'm going to have y'all vote on it. So we are starting a poll. Ignore the yes, no in the poll. I don't know how to get rid of that yet. All right. So the choices are, for our next concept, dividing fractions is one option. So new poll is up. So for the new poll, at the 24-minute mark, here's our 4 options. Converting mixed numbers to improper fractions, so the opposite of what we're doing right now. Adding and subtracting fractions with like denominators. Dividing fractions, or the butterfly method. And the butterfly method is a strategy for if you have unlike denominators. All right, so that's the new poll. The new poll is up. Vote on it. Around the 30-minute mark, I'm going to count the votes. All right. In the meantime, next example. 7/2. So we're going to make 7 total tallies, and we're going to make them in groups of 2. So 1, 2. We have one group of 2. 3, 4. 2 groups of 2. 5, 6. 3 groups of 2. We now have our 7 total tallies. So we were able to get 3 full groups of 2. 3 is our whole number. Our denominator stays the same. Denominator is 2 for the improper fraction. The denominator is going to remain 2 when we convert it to a mixed number. Our remainder is our numerator. We have a remainder of 1. So 1 will be our numerator. So 7/2, or 7 seconds, converted to a mixed number, equals 3 1/2. All right, moving on to the next example. Is the Mr. Camilleri show. You were not mistaken. 3 1/2 was correct. Is the Mr. Camilleri show. Shout out to Mr. C. I might have to change the color of the marker here because I like variety. So here we go. All right, the next improper fraction is 10/4. So we got to figure out how many groups of 4 go into 10. So we're going to make 10 total tallies. We're going to make them in groups of 4. 1, 2, 3, 4. That's one full group of 4. 5, 6, 7, 8. 2 full groups of 4. 9, 10. All right, we now have our 10 total tallies. We were able to get 2 full groups of 4, so 2 is our whole number. Our denominator stays the same. Our remainder is our numerator, so 10/4 converted into a mixed number equals 2 2/4. Now I understand that 2 2/4 is not lowest terms. Reducing fractions to lowest terms, that could be another concept. I probably should have put that in the poll, but that's another concept that we can do. I might put that in the next poll if we have another poll on the stream. All right. I gotta say, holding a phone gets tiring after a while. Too much phone time is not always a good thing. All right. Next example problem. So far, we only have 1 vote. I'm allowing y'all to vote on what you want the next concept to be. This is the fraction satisfaction live stream, so vote on what the next concept you want for fractions. Vote on what you want it to be. I only have 1 vote so far. In the meantime, we're going to keep converting improper fractions to mixed numbers. All right, 17/8 is next. So I'm going to make 17 total tallies. I'm going to make them in groups of 8. 1, 2, 3, 4, 5, 6, 7, 8. That's one group of 8. 9, 10, 11, 12, 13, 14, 15, 16. That is 2 groups of 8. 17. We now have our 17 total tallies. All right. Now we were able to get 2 full groups of 8, so 2 is our whole number. Our denominator stays the same. Our denominator is 8 for the improper fraction. It's going to remain as 8 for the mixed number. Our remainder is our numerator, and we have a remainder of 1. So 1's our numerator, and 17/8 converted to a mixed number equals 2 1/8. All right, here we go. Next example. Think around the 27-minute mark, I'm going to check the poll, see what you all want our next concept to be. Eight thirds. So we're going to make 8 total tallies. We're going to make them in groups of 3. 1, 2, 3. We have one group of 3. 4, 5, 6. That's 2 groups of 3. 7, 8. So we have our 8 total tallies. We have 2 full groups of 3. 2 is our whole number. The denominator in our improper fraction is going to remain the denominator for our mixed number. So 3 is our denominator. Our remainder is our numerator. We have a remainder of 2. So 8 thirds equals 2 2/3. 8 thirds is a mixed number equals 2 2/3. So far, we only have one vote on the poll. Ladies and gentlemen, do not take your right to vote for granted. That is very, very important. It is important not to take your vote for granted on this live stream, and it is also important in life. All right, so vote on the poll. In 1 minute, I said the 27-minute mark, but I'll give you out to the 28th. In 1 minute mark, at the 28-minute mark, I'm going to tell you what the next concept is going to be on the fraction satisfaction live stream. All right, one more though. 12 sevenths. We have to convert 12 sevenths to a mixed number. So we're going to make 12 total tallies. And we're going to make them in groups of 7. 1, 2, 3, 4, 5, 6, 7. So we have one full group of 7, 8, 9, 10, 11, 12. So we have our 12 total tallies. We have one group of 7, so 1 is our whole number. Our denominator stays the same. Our remainder is our numerator. So we have a remainder of 1, 2, 3, 4, 5. So 12 sevenths converted into a mixed number equals 1 5/7. Now looking at the poll. All right, we had a vote for adding and subtracting fractions with like denominators. All right, so that'll be the last concept of this fraction satisfaction live stream, adding and subtracting fractions with like denominators. So we'll start with the adding fractions with like denominators. Here we go. So adding fractions with like denominators is actually very simple. It's just like adding whole numbers. The only difference is that the denominator stays the same. So we would add the numerator just like we would add any whole number. What is 2 plus 1? 2 plus 1 equals 3. Now because our denominator is the same for both fractions, it's going to be the same in our answer. So 2/8 plus 1/8 equals 3/8. All right, next adding fractions example. I'll do 2 of each. I'm going to do 2 of each, and then we will call it a video. All right. 7/10 plus 2/10. All right, so step 1, we add our numerators. 7 plus 2 equals 9. Ten is our denominator for both the fractions. 10 is going to be the denominator In our answer, the denominator, aka the bottom number, stays the same. 7/10 plus 2/10 equals 9/10. All right. Now an example for subtracting fractions with like denominators. Two subtracting fractions with like denominators. Examples. All right, we have 4/5 minus 1/5. So same concept, only difference is now we're subtracting instead of adding. So we subtract our numerators, we keep our denominator the same. 4 minus 1 equals 3. Our denominator is 5 for both fractions. Denominator is going to be 5 in the answer. 4/5 minus 1/5 equals 3/5. All right. Stay tuned for the final example of the video. All right, 7/8 minus 5/8. So we start out, we subtract our numerators. 7 minus 5 equals 2. Our denominator stays the same. Our denominator is 8 for both the fractions here. And we have our answer, 7/8 minus 5/8 equals 2/8. Now that answer is not reduced to lowest terms, but reducing fractions to lowest terms, we'll save that for another fraction satisfaction live stream. But that is my video for today. Thank you so much for tuning in. Leave a comment. Let me know what you thought of the video. And if there is an area of math or reading that you're having difficulty with, put that in the comments and I will do a future video on that skill. Until next time, this is Mr. Camilleri. This is the Mr. Camilleri Show YouTube channel, and I am signing off.